Hi again. Hopefully you just watched the video on population proportion, which will help homework number 16. Um, and now in this video, we're going to look at population mean, which will help you to tackle problems in homework number 17. I'm going to come back to this slide in just a minute. Let's take a look at a question first. Suppose that we randomly selected 56 students at Bunker Hill Community College and found that their average height, their average height was 65 inches. Their average height of these 56 people is 65 inches with a standard deviation of 4. So with that information from my little sample study, can we estimate the true Bunker Hill mean height with a 90% confidence? So what we're doing in homework 16 and 17 is using what is very big in statistics. We're taking a sample population, we're studying a sample group of people, and then using that data to draw conclusions about the population as a whole, because it would take forever to measure every single person at Bunker Hill. So again, like the last video, we're not going to find that exact mean height, but we will find a range, right? We will find an interval is what we call it, right? So in the previous slides, this was the formula we had, the true population proportion percentage was lying between the percentage of your sample plus the error and the percentage of your sample minus the error. And then we had a formula for that error, and then these are what all the parts of the formula are. And if you look over here at population mean, which is what we're going to be doing now, it's very similar, except now we're trying to find that true mean rather than a true percentage. And that's really the only difference. And in this case, the true mean of your population, okay, it's going to lie between your sample mean, which you're given, plus or minus that error again. So the work comes in finding the error. And here is the formula for the error. We're not going to get into the specifics of where the formula comes from, but we're going to practice using it for the time being. Okay, so the error comes from very similar to over here, except now instead of P's and Q's, we have standard deviation. So again, we have that critical score, Z, alpha sub 2, times the standard deviation divided by the sample size. And everything's here for you to refer back to, and most importantly, that critical value. Okay, so if we go back to our question, we are told we have a mean. So in this case, our mean, and this time we're going to be putting a hat over it. Our mean hat is going to equal 65, and our standard deviation equals 4 inches. 4 inches or 65 inches. We then need to find the critical value, and ultimately we're going to need to find the error, right? Well, we want this to a 90% confidence. That's what we need to find the critical value. So let's pop over to another slide and figure out the critical value for 95% confidence. Okay? All right. Okay, I set this up so we can do it rather quickly because we've been spending a lot of time on finding critical values, and I think you're pretty familiar now with the normal distribution curve in the z-table. But a critical 90% confidence means that 90% lies right here in the middle. And so these are our two critical values. These are the z-scores we have to find. And remember that if this area under the curve is 90% or 0.9000, then these two remaining parts are 1 minus that 0.9, which is equals 0.1 or 10%. So half of it is on this side, the 5%, the other half is on this side, 5%. And that 5% can be written as 0.0500. We'll write it as a decimal so we can use it to look at our z-table. And again, we're going to use this negative side because our z-table always gives us values to the left. So let's pull up that z-table. Here it is, and we're going to try to find 0.0500. And look, there is no exact value. There's 0.0505 and 0.0495, okay? And in fact, there's a dot right here for that very reason, because this is a very significant critical value. It's a very commonly used one. So we're actually at negative 1.6, halfway between 4 and 5. So negative 1.645. We'll carry it out 3 places this time. All right, so let's go back to our work and write that down right here on our negative 1.645, and over here it's 1.645. And so for our purposes of the formula, at this point we're just using the positive value. We have now found our critical value to be 1.645. So we're going to close this out, go back to our original slide, and we now know our confidence, our z-score, or our critical value is 1.645. Okay. So now all that's left is to find the error, and the error has its own formula. The error is equal to the critical value of 1.645 times the standard deviation, which we are told is 4, divided by the square root of n. And remember, n, I did actually forget to write that down. N was, how many people did we ask? 56. 56 people were questioned in our sample. So yes, 56. That's important to write down too. All right. Now, if you do that on your calculator, again, be careful. You want to do 4 divided by 56. Here, hit the square root button, and then equal, and then multiply it by 1.645. If you're having trouble with that, and let me know in class. And that's going to equal 8.880. Okay, so that's our error. And in this case, because we're talking about the mean and we're working in inches, this is 0.88 inches. That's the error. That's how much it's going to be off. So in the end, our true mean is going to lie between, change my color here, going to be less than the sample mean of 65 inches plus that error of 0.88, and 65 inches, the sample mean, minus 0.88. And if you do that on your calculator, then the true mean is going to lie between 65.88 and 64.12 inches. That is where the true mean of Bunker Hill students' heights lie. All right, so let's take it back to our question and or summarize, okay? So in the end, we are 90% confident that the true mean of our BHCC students lies between 65.88 inches and lies between 64.12 inches and 65.88 inches. That's what it means in language terms. And again, just like before, another way you might see this written is the lower limit of 64.12 inches and an upper limit of 65.88. Okay. So just be careful with your calculator and go for it. You can now attempt problems in homework number 17.